is about binomial expansion. So previously we have this for the f of x. So 3 over x minus 2 minus x plus 6 all over 2x squared plus 3. Notice that we use plus here to make things simpler in the end. So we never use this formula in the MF19 because this is for pure 1, because the n we are dealing with is not positive integer. Usually it's negative or a fraction. So for the first term, the one in black, 3 over x minus 2, we can rewrite this as 3 times x minus 2 to the power of minus 1, and we can make it 2 minus x here, so we pull out the minus, so we can put the minus outside like this. This is actually still minus 2 plus x, same thing. Now if you look at the MF19 formula, here we have 1 plus x, which means we can only use the formula if this is 1. If this is 2, we cannot use the formula, so we're gonna have to factor out the 2 here. So we factor out the 2, we get 1 minus 1 half x. Notice that if you expand, you're gonna get 2. If you expand, you have to get minus x. Now remember, the square brackets is important because the 2 is also to the power of minus 1. So now we have 2 to the power of minus 1 times 1 minus 1 half x to the power of minus 1. Now 2 to the power of minus 1 is actually 1 half. Minus 3 times 1 half is minus 3 halves. Now for this part, now we can use the MF19 binomial expansion pure 3 formula. So we just follow the formula, we replace the x in the formula here with minus 1 half x, and we replace the n in the formula with minus 1. So just follow the formula, we have 1 plus nx plus n minus 1 over 2 factorials times x squared. We don't need to continue because we are only expanding until x squared term. So we stop right here and we simplify, we get 1 half. We simplify, use a calculator, you should get 1/4. Make sure you know that the minus 1 half is also squared. And then we multiply, minus 3 halves times 1, we multiply, we get the simplest form in ascending powers of x. And for the second term, same thing. We use the loss of indices, negative power, first step. And we can just rearrange a little, switch the order. And we cannot use the formula if it's 3 plus something. It's gotta be 1 plus something, so we pull out the 3 from each term. If we expand, we get 3. If we expand, we get 2x squared, so we're not changing anything. The 3 is also to the power of minus 1. 3 to the power of minus 1, which is 1/3. So this 1/3 just multiplied with this term, with this factor here. So 1/3 times minus x, 1/3 times 6. We have something simple here. Now for the 1 plus 2/3 x squared to the power of minus 1, we have to use the formula. We replace the x with 2/3 x squared and the n with minus 1. Using the formula, we get 1 plus nx and so on, but we stop right here because again we don't want to continue and use the x to the 4th term. That's useless because we don't need x to the 4th term. So this is all we need. Now we simplify, this is minus 2/3, and then we multiply. Minus 1 half x times 1, we get minus 1/3 x. Minus 1/3 x times 2/3 x squared, we will get x cubed term, and we don't need x cubed here. So there's no need to multiply these two terms because we don't need x cubed term. So we ignore that one. Now we do 2 times 1, which is 2, and 2 times minus 2/3 x, which is minus 4/3 x squared. So we rearrange the constant term first, the x term and the x squared term, and then we add everything in the end. So it's a plus here to make it things simple. We don't need to use brackets. Now we use a calculator, simplify, we get 1/2, and simplify, we get minus 13/12. Simplify, use calculator, we get minus 41/24. So that's the final answer. Alright, I'll see you again next time.